Week 6B, Test 1 Mock. Answers and explanation. Okay, I'm going to assume you've either done this mock test in your 6B lab or you've got hold of the papers outside class. Essentially, I'm going to assume you've been able to get hold of the question paper and the data file and you've been able to open them. I'm not going to deal with those processes. I'm going to leap straight in to the first question. Actually, the first 9 questions all relate to this simple study described at the beginning. Please forgive my taste for somewhat stupid names like Professor Twiddlethumbs. But anyway, we have this hypothesis that psychology students have better social skills than other undergraduates. We've got this social skills scale, the TTSSS, and the way that works is that the higher your score, the more socially skilled you're thought to be. So basically, this professor thinks that psychology students will have a higher score on the TTSSS. It's important to note that the scale goes from 0 to 50. Anything outside of that is clearly nonsense. And that the questionnaire was given to 30 psychology undergraduates and 30 people studying something else. The next bit relates to the data file. So I'm now showing you a bit of the data file to the left here. And it's basically saying that the first column of the data set, currently labelled var 00001, contains the TTSS scores. So all these numbers down here are the TTSS scores. And the column next to it, var 2, all the numbers down here, code whether the student is studying psychology. If they're studying psychology, it's coded with a 1, so this person down here in the 15th row, they're studying psychology, and a 2, such as the person in row 17, codes the fact that they're studying something else. Now, finally, we're ready to talk about question 1, and that just asks you to add some variable names and some variable labels to the data file. But once you've done that, you need to generate a table of descriptive statistics for both variables and copy and paste that table into the area immediately below the question, so about there. Now to do that, we obviously need to go to SPSS, and actually we need to be in the variable view to be able to perform those operations. So we go down to the bottom of the screen and clicking on the variable view button there, we're now able to work with the variables rather than the data. Okay, first of all, remember that variables are columns in the data view, but in the variable view that we're in now, each variable is its own row. So all that's highlighted now relates to variable 1, and all that's highlighted now relates to variable 2. So to change the name of variable 1, we'd simply double click in the name field for that variable, delete what's already there, which doesn't really help, and just for now put something like TTSSS for the TTSSS scores. For variable 2, we just click in there and we'll call this something like discipline. To add the labels, we just need to go to the label field for the first variable, double click there and start typing. Something like Twiddlethumbs social skills scale. And then do the same for the second variable, something like subject studied. Doesn't particularly matter exactly which words you use. Now we need to get our table of descriptive statistics. For this we need to go up to the Analyze menu, down to Descriptive Statistics, and from the sub-menu that pops out there, simply choose Descriptives. And then in the dialog box that appears, we simply select both variables in our data set from the list on the left, move them over to the box on the right, and click OK. This will take us to our output file where we can see the required table of descriptive statistics. Remember, what we need to do now is to copy and paste this from our output file into our Word file. So I'm just going to go to this table, right click on it, say copy. Then I'm going to shift to Word, go to question 1, go immediately beneath that, right click again and go paste. And there we are. Now we can move on to question 2, and we can pick up the pace a bit. Okay, question 2 asks you to screen the data, deleting any cases that contain anomalous or missing data. And then once we've done that, you need to get a fresh table of descriptive statistics for both variables and paste that into the Word document. Now, for screening the data, you need to pay attention to the information given to you at the beginning of the question paper. And this is the information that the TTSSS scores can range from 0 to 50. But also that the questionnaire was given to 30 psychology undergraduates and 30 undergraduates from other disciplines. In other words, a total of 60. Now, if we turn to our descriptive statistics that we generated for question 1, we can look at those to see whether we think there's going to be any problems with screening the data. Now, the first thing to look at is our set of n's. Remember, these are simply the number of valid data points in each variable or column. And we can see that the Twiddlethumb's social skill scale, say that quickly, variable has only got 59 data points as compared to the 60 for the other variable. Now, that clearly tells us that the TTSSS column has one case, one row with missing data. That's a problem. That case has got to go. Now we need to turn to look at the minimum and maximum values. Okay. Now we can see that for subjects studied, we should have just 1s and 2s, and that's what we've got. Minimum of 1, maximum of 2. That all seems fine. But when we turn to the TTSSS scores, we've got a minimum of -1 and a maximum of 117. Now remember, 0 to 50 are the limits of the scale, so there's clearly at least one score that's below the minimum of 0, -1, and at least one score that's above the maximum of 50, 117. So this gives us a pretty good idea of what to look for in our data set when we go about screening. To do the screening, we need to go back to SPSS, we need to go back to our data file, and it's best to be in data view. Now we can just scan through the data trying to find the ones that look a bit odd, but probably the most systematic way of doing this is to sort the data. Go to the data menu and choose sort cases. And then in the dialog box that appears then, choose the first variable, the TTSSS, as the variable we're going to sort the data set by, and move that one over to the box on the right. Click OK. Now if we look at our data file, we can see that right at the top is that case with a missing value. Okay, we know they studied something other than psychology, but we don't know their TTSSS score. They're no good to us. We can get rid of them. We'll just select and right click to get rid of them. We can now see that the first row now is that case with the negative score. Remember, our theoretical minimum on the TTSSS scale is 0, so this case must be wrong. Again, right click there, clear that. And now we can scroll to the bottom of the data set, and the very last case shows a TTSSS score of 117. This is the one that's clearly above our theoretical maximum of 50. We can again just get rid of that. However, if we just check and go back, we can see that what is now the last data case It's also above our theoretical maximum of 50, 66. So this too has to be deleted. Right click, clear. I'm not going to go through again how to generate descriptive statistics or copy and paste from SPSS into Word. It's just a repeat of what you did for question 1. But once you've completed those operations, you should have a table that looks like this. And now we can see that our ends are all the same at 56, and our minimum of 0 and our maximum of 48 are both within the permissible limits of the scale. So screening is now complete. Question 2 is now done. On to question 3. Now the first thing we're asked to do here is to add value labels to the second column, to the second variable, the one I named discipline and gave the label subject studied to. Now clearly, to do this we need to go back to our SPSS file, the data file, and be looking at it in our variable view. Now the values that we want to add labels for are that in this second variable, discipline or subject studied, a 1 should be labelled psychology. A 1 codes that psychology is the discipline or subject studied, and that a 2 should be labelled other discipline or something else, because a 2 is used to code a student who's studying something other than psychology. Now to do this, I need to go to the values field for that second variable, discipline. If I click in there, you see just on the right hand side this little button. Click on there and this dialog box appears. Now if you recall, a 1, the value 1 in that column, that variable, codes for a student studying psychology. So we want the label psychology for the value 1. Click add. A value 2 needs the label other, let's say. Again, click add, click OK. You can check that everything's okay if you switch to your data view and see whether you've got those labels you just entered in your second column, your second variable. If there's still 1s and 2s yet you're sure you've done it right, don't forget to check up in the toolbar to see what's happening with this icon there. Clicking on that button toggles between the display of these value labels and reversion to the actual numbers underneath them. Now we've added our labels, we can move on to the second part of the question, which involves generating a custom table showing descriptive statistics. To do this, I need to go to the Analyze menu and from there choose Tables. From the small sub-menu that pops out there, choose Custom Tables. You'll then have this quite large dialog box here with your variables listed down the left and then a big space off to the right. Basically, we just need to choose which variables we want to define our rows and which ones to define our columns. I quite like having my nominal or ordinal variables defining the rows. So I'm going to drag the subject studied to where it says rows, and therefore dragging the other one, the TTSSS scores, over to where it says columns. Now we need to specify which descriptive statistics we want to include in our table. First of all, make sure that the dependent variable, the variable we're actually summarizing, is selected in our table. So where it says Twiddle Thumbs Social Skills Scale, make sure that's highlighted yellow, meaning it's selected. Here's not selected, there's selected. And once it is selected, you can go down to the bottom left where it says Define Summary Statistics. Just click on that Summary Statistics button and this little dialog box pops up. On the left hand side, we've got a list of all the different statistics we can have in our table, and on the right hand side we place the ones we do actually want displayed. You can see that the mean is already there as a default. That's great. That's one of the two we need. We just need to look down the list to find standard deviation. There it is. And move that over to complete the set. Haven't quite finished. The question does ask for both the mean and the standard deviation to be displayed to 2 decimal places. Now we can see some fields over here labelled decimals, and they would seem to be what we need to get into to be able to change the decimal places displayed, but we can't seem to do anything with them. What we need to do first is change the format of the cells. At the moment it says auto. If you double click there, get a drop down menu, and you should choose the first option, somewhat telegraphically called NNNN, which basically just means it's going to show the basic numbers. And once you've changed the format to that, you can see we now have an entry in the decimals field, 0. We click there, we can shift that up to 2, which is what we want. Repeat that for the standard deviation, and now everything's set up as we want it. Let's just check that's right, yes. Click apply to selection, and we're almost done. Just one more thing to do. That last thing we need to do is to give the table a title. If you look up towards the top of this dialog box, this list of tabs here, we've been dealing under the tab table. We click on the tab titles. That gives you a place you could add your titles. Just use the top box. This gives a general title for the table as a whole. Click in there and then type whatever title you think is appropriate. I'm going to put something like descriptive statistics for TTSSS scores as a function of subject studied. You can have something longer, but just as informative, please. And once that's done, you can go back to table, it doesn't really matter, and click OK in the bottom right. This will then take you to your output file as usual and show you your custom table. And that is exactly the table, title included, that you need to copy and paste back into the Word document immediately below question 3. Moving on, you've probably noticed that question 4 and question 6 are quite similar. They both ask you to generate a frequency distribution. Question 4 asks you to produce one just for the students who studied psychology, whereas question 6 wants you to do it for the people who study something other than psychology. And you're then asked to make some adjustments and give each a title. But both of them involve you producing a frequency distribution. The point is that for each of them, you're not using all of the data. For each chart, for each frequency distribution, you're only using part of the data. There are different ways of going about this. One way is to use the select cases method. To do this, you go up to the data menu within SPSS, and from that choose select cases. In this dialog box, you then specify that you want to select cases on the basis of a condition being satisfied. Click on the if button to specify what that condition is, and if we say we're going to start with question 4, which wants a frequency distribution just for the students who studied psychology, then we would say that our condition to be satisfied was that the subject studied, or discipline, is equal to 1, because we're using a 1 to code for psychology. Click continue, and then OK. Then you can see in the data file that rows which contain someone studying psychology, such as row 1 or row 4, they're as normal, but rows containing someone studying something other than psychology, such as the person in row 2 and that in row 3, they have a line through their row number. They will then be excluded from the analysis you're about to perform. Now you've selected the psychology students, you can go about making your frequency distribution. For this, you need to go up to the Graphs menu and choose Chart Builder. You can click OK to this dialog box. We need to produce a histogram, so if we choose histogram from the gallery at the bottom half of the dialog box, and we just want a simple histogram, so we just double click on that first option. Moving now to the top half, we just need to select and then drag the variable we want graphed, which is the TTSSS scores. Drag that down to where it says x-axis and then simply click OK. This will give you the following frequency distribution. Two things we need to do. We need to adjust the binning and give it a title. To do both, we need to start editing the chart by double clicking on it, and a chart editor pops up. Let's start with the binning. To adjust that, you need to double click on the bars of the chart itself, not anywhere else, not just in the general chart area or around the axes or something like that, on the bars of the chart itself. When you do that, the properties window that pops up will have the binning option. And amongst the binning options is one to set a custom value for the anchor, the lowest point on the x-axis. Choose that option, make it available, and simply enter 0. Click Apply. You can then close the properties window and you'll see how your graph has changed. Now the anchor, the lowest point, is 0. Now we just need to give it a title. We can just go to the Options menu and choose Title. This then gives us this field just above our chart where we can select the word that's already there, delete that, and put in something more appropriate. Something like frequency distribution of the psychology students TTSSS scores. Okay, once you're happy with that, because remember a title needs to say what kind of graph it is, what data's included in it, and whose data's included. But once you've done that, close the chart editor and you're taken back to your output file, and there is the part of the output file that you need to copy and paste into the Word document. That's question 4. For question 6, you could just go back to Select Cases from the Data menu, go back to your condition, change it from discipline equals 1 to discipline equals 2. Then you can go back to your chart builder, simply click OK, and there you have your other graph. You need to double click that and edit it in the way we just went through, but that is essentially one way of generating the 2 histograms from different parts of the data set that are required for questions 4 and 6. There is, however, another way, which is probably quicker, which is to use the Explore command. Now to do this, you need to make sure all the data's included, so we just need to pop back to Select Cases and choose All Cases. Click OK. But now we just go Analyze menu, Descriptive Statistics, Explore. We choose TTSSS as our dependent variable and discipline or subject study as our factor. We only want plots, and we choose which plots we want by clicking on the Plots button. Say none for the box plots. Don't want stem and leaf, just histograms, thank you very much. Click Continue and then OK. And what you get after all that is, after some summary tables, are your 2 distributions. They need editing just like the distributions form the other way did, but they're basically there. You need to adjust the binning and edit the titles. But that's another way of producing the two histograms. We'll move on now to question 5, where you're asked to describe the shape of the distribution that you generated and then copied and pasted for question 4, the distribution of scores of the psychology students. Now, the first thing to say about this distribution is that it's not symmetrical. The data's off to one side. It's therefore skewed. But you also need to decide in which direction it is skewed. Don't let your attention be dominated by the bulk of the data being over here. The trick here is to look for where the tail is. On what side of the distribution does the data peter out and form a tail? For this distribution, it's over to the right-hand side, and therefore the tail points in that direction, towards the positive end of a number line. And so for that reason, this kind of shape of distribution is known as one that's positively skewed. Turning now to question 7, where you're asked the same question to describe the shape of the distribution, but this time for the other distribution you made, the one you pasted for question 6, the distribution that's created from the data from students studying disciplines other than psychology. Again, this time, the distribution is not symmetrical. The data's more to one side than the other. It's easy to see that it's skewed again. However, this time, the tail is more over to the left-hand side, pointing in that direction, towards the negative end of a number line. And so this distribution will be described as negatively skewed. I'd like to turn now to question 8. What's the probability of a randomly selected psychology student having a TTSSS score of at least 26? Now, to answer this, you need to be familiar with the material presented in week 5B, in that learning module. It's actually reasonably simple to work out. Although you use the data that's in SPSS, you don't actually use SPSS to calculate the answer. In particular, the piece you need from week 05B is this simple definition or formula for calculating probabilities. You simply need to know the proportion of possible outcomes that meet your criterion. So really, to answer this question, we just need to turn to our data set and find out the two numbers concerned: the total number of possible outcomes and the number of qualifying outcomes. The total number of possible outcomes is simply the number of psychology students we've got left in our data set. The number of qualifying outcomes will be the number who score at least 26. Let's go back to the data set and find those things out. There are various ways of finding out these two pieces of information. Given the small dataset concerned, probably the most straightforward is simply to sort the cases so that we can more easily simply count them. So if we first of all sort by subject, that will force all the psychology students to the top of the data file. We can then simply count how many rows of psychology students we've got. Then we can sort by their TTSSS scores. That will make it easy to see how many of the psychology students have scored at least 26. Okay, here's our sorted data file. You can see we've just got psychology students, psychology students, psychology students at the top, and then it switches to all the other ones. But we can see our psychology students come to an end after 29 rows. We have 29 psychology students left in our data set. This means we can write in the bottom half of our fraction as 29. The total number of possible outcomes is the total number of different psychology students in the data set. That's 29. going back to our data set, all we need to do now is count up how many psychology students scored at least 26. That means 26 or higher. Now remember, this is a sorted data set now, so this is very straightforward. We simply look back up our list of psychology students, find where 26 falls, there it is, and see how many there are including that person until the end of the psychology student. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 psychology students who scored at least 26. We can now write in the top part of our fraction the number of qualifying outcomes, which we've just counted, to be 8. So our probability is 8 out of 29. But you remember that we need to express our probabilities not as fractions, but as decimals or percentages. So quick use of a calculator would tell you that that comes out to 0.276, or approximately 28%. We can now turn to question 9. Are the means for the two groups of students consistent with Professor Twiddlethumb's hypothesis? Now, a key word here, or something I want to focus on, is the notion of the means being consistent. Not talking about them proving his hypothesis, heaven forbid, or even providing clear support. We're just looking at the means. We're not doing a proper analysis of the outcome of this study, made up though it is. Okay, we're just having a look at whether the means are consistent with his hypothesis or not. The kind of formal analysis that you really need to do with data is the subject of the next block of this module. Now we're just looking about whether the means agree with his hypothesis or not. Here's a reminder of that hypothesis. Basically, it's the idea that psychology students will have better social skills than the other undergraduates. And the way the TTSSS scale works is that the higher your score, the more socially skilled you ought to be. So psychology students should have higher TTSSS scores. The mean for the psychology group should be higher than the mean for the other group if the means were consistent with the hypothesis. Here are the means. You produced these earlier for one of the earlier questions. Okay, the means in question are here. Psychology, just over 18.5. Students studying other disciplines, almost 33.5. Well, it's clearly the case that these means are not consistent with Professor Twiddlethumb's hypothesis. The answer to the question is no. In fact, they're the other way round. The psi mean, rather than being higher than the mean for the other group of students, is in fact lower. Finally, we can turn to the last set of questions. These are questions 10 to 13. And I think it's fair to say, for all these remaining questions, you really need to have worked through the learning modules for week 05B before attempting them. And to a lesser extent, but it's still the case, 4B as well. I haven't got the time or space in this nugget to reteach the material conveyed in those 2 weeks, particularly not week 5. And so, what remains of this nugget will essentially run through the answers for these questions. Okay, so the first of these questions, question 10. The preamble to this is that Annie isn't sure how well she's done in her statistics exam relative to other students in her year. Her tutor tells her that her grade has a Z-score of +1. Question 10 is, what does a Z-score of +1 mean? What I need you to convey here is your understanding that what a Z-score is a count of how many standard deviations a score is away from the mean. So having a Z-score of 1 means that your score, Annie's score, is 1 standard deviation away from the mean. However, because Annie's score is +1, you also need to convey that the positive sign of her score means that her score on the statistics exam, is above the mean. The full answer is 1 standard deviation above the mean. Question 11. Approximately what percentage of other students in her year scored as well as Annie or better? Now you're told in the question above that Annie's score has a Z value of 1. In other words, Annie is here. Now the students in her year who scored as well as her or better are to the right of her. So it's all this area here, all the area to the right of Annie. Now you're told, both in this diagram and elsewhere, that there's 14% between 1 standard deviation and 2 standard deviations. So you're almost there. We almost know the answer already. But there's this bit as well. How much is there? That's what we need to know. Simple subtraction. It's a symmetrical distribution, so there's 50% to the right of the mean, and to the left, obviously. So this bit at the end must be 2%. 34 plus 14 equals 48. So therefore the answer to the question, what percentage of other students in her year scored as well as Annie or better, is 16%. Both question 12 and 13 have the same preamble. Dr. Smiley, another one of my stupid names I'm afraid, is working with data from the National Happiness Survey. The distribution of happiness scores from the UK is a mean of 100 and a standard deviation of 10. Stephen, a UK citizen, has a happiness score of 80. I think I wrote this question quite late at night. Question 12. Convert Stephen's raw happiness score into a Z score for Dr. Smiley. You'll recall from learning module 5b that the formula for working out a Z score is very straightforward. Z is equal to the score itself minus the mean of the distribution you're working with divided by the standard deviation of that distribution. Okay, so for Stephen we can say that his score is 80, the mean of the distribution is 100 and the standard deviation is 10. Moving up to the right here, the top half of that, 80 minus 100, gives you minus 20 divided by 10, which means that our answer, the Z score that Dr. Smiley's after, is minus 2. Okay, the very last question, question 13. What's the approximate probability of a randomly chosen UK citizen having a happiness score the same as Stephen's or worse? Keyword here is worse. Okay, we just worked out for question 12 that Stephen has a Z score of minus 2. So he sits there. Now we're working out the probability of someone having a score the same as Stephen's or worse. That means we're looking for this area here, the area of the distribution to the left, below Stephen's score. Okay, what is that area? That's the probability we're after. Now the trick to this question is to remember that the distribution, this standard normal distribution, is symmetrical. So whatever applies above the mean applies equally, but mirrored, below the mean. So if we've got 34% between the mean and 1 standard deviation above the mean here, it also applies that there's 34% between the mean and 1 standard deviation below the mean. Simple mirror image. So we've got 34% there. It's equally true that we've got 14% between minus 1 and minus 2 standard deviations. And it also applies, as we worked out earlier in regards to Annie, that this part here beyond 2 standard deviations is 2%. And that is simply the answer to the question. The approximate probability of a randomly chosen UK citizen having a happiness score the same as Stephen's or worse, because Stephen has a Z score of minus 2, the answer is 2%. Well, that's it. That's the mock finished. Hope it wasn't too bad. Hope I didn't bore you too much. If you found that difficult, I can understand that. It's a lot of material there. But practice is the key. If you stick at it, keep working with SPSS, keep reading through the conceptual material, and you will get it in the end.